Hello and welcome to this Edexcel GCSE Geography topic review on weather and climate. This is just a short review of the key information from the topic. It's not everything that you need, but you could use this along with your class notes, revision guides and your own revision notes to get as much detail and understanding as possible. Also, when you've watched this, have a go at making your own version of the mind map, or even try and have a go at making a video and send it to me, and I'll have a see what I think. So, as always, when we look at the topics, it's important to go back to the specification. This gives us the key terms and the key areas we need to focus on. So we can see for the weather and climate section, we've got the overview here. Now this is looking at the different physical processes and systems that operate for the climates, and it allows us to understand about the global and UK climates and how the climate is changing. We then need to look at some specific examples of different types of weather hazards in tropical cyclones and drought. And for both of these, we need to look at case studies for a developed and an emerging or developing country. So let's have a look. Here is the mind map for the whole of the weather hazards course. And what we're going to do is break it down into each of the sections. So first of all, we need to know the physical processes that look at climate around the world. Now, what we have is some very badly drawn diagrams. The first one here shows us the atmospheric circulation. This is how the heat energy from the sun's rays can lead to the transfer of heat through these atmospheric cells around the globe. At the equator, we find that this is where the sun's rays are most concentrated, therefore there's the most energy, which leads to this rapid rising of air. This forms a low pressure because the air is rising, there's less pressure on the surface. As the air rises, it cools, forms clouds and leads to hot and wet conditions around here. Now, as the air can't go out of the troposphere, it then gets pushed to the side by the more rising air until eventually it starts to fall down. Now, as the air is falling, it's creating high pressure on the surface. As the air falls, the water evaporates into it, so it becomes clear. So we tend to get very hot and dry conditions. Then back along the surface, some of this air then returns back to the equator. So in the equatorial areas, we tend to have hot and wet conditions. And at the tropics, we have the hot and dry conditions, often the deserts. And as the air is returning from the tropics to the equator, these zones here are also quite dry. Now this is very important because it links greatly to the setting up of the different ecosystems, which you'll see in another video. Now some of the air which is descending here is also drawn into more temperate latitudes. So here we tend to get this warm, dry air rising up to higher latitudes. Now also what happens though is we get this cold air, this other high pressure, which is being forced down. And here we have a battleground where we have cold air and we have warm air. And as the cold air meets the warm is forced above it, which can lead to clouds and leads to rain. And these can lead to low pressure systems forming around these temperate areas. So here we tend to get cooler but wetter conditions. Now, this is a very simplified version of how it works. We have the Hadley cell between the equator and the tropics, the Ferrel cell, and then the polar cell. So this is a very simplified version of it. Another way that heat gets circulated around the planet is through thermohaline circulation, or the oceans. And what we have very simply is the warm water at the equator is often then moved by trade winds and ocean currents to other areas. And this is very important for the UK because we get the Gulf Stream, which brings very much warm water, which leads to us being much warmer than we actually should be at our latitude. This warm water then gets up to cooler areas, it sinks, and the cold water then travels down to replace the warm water here, setting up these different cyclical systems. Now, as we look at this, these are probably some more detailed diagrams, but I can't draw as well as that on mine. But this is a time to have a pause and have a look and remind yourself of the different systems. So we also need to look at, though, is how is the climate changing? Now, the climate has always changed over millions and billions of years. And over the last few 100,000 years, we've seen that the world has been in these glacial or colder periods and these interglacial or slightly warmer periods. And over these hundreds of thousands of years, there have been a number of physical causes. The key one is the Milankovitch cycles. This is where the Earth's orbit around the sun changes, meaning that it's further away for longer or closer for different periods, changing the amount of heat energy or radiation it receives from the sun. But we can have shorter term changes in solar outputs. So sometimes the sun can be giving out more or less energy, which will lead to more or less heat. Volcanic eruptions are another one where sometimes the emission of the gases and ash into the air can block the sun, cooling temperatures down. Now, the physical causes are all led by something called the greenhouse effect, which is completely natural. This is the carbon dioxide and other atmospheric gases which help to trap and reflect some of the heat energy that's reflected back off the Earth, a bit like a blanket over the ground. Now, how do we know this? Well, there's plenty of evidence going back hundreds of thousands of years. The longest evidence we have is through ice cores, which as the snow falls and lands, it traps air in it, which traps the different gases, and we can drill down into the ice sheets and actually record how much CO2 is in there. We can also look at pollen layers. We can look over thousands or hundreds of years at tree rings. The growth of the tree rings or the width of the rings can tell us what the climate was like. And we can also look at reading books, looking at pictures and drawings, which give us evidence of what it was like. Now, things have changed rapidly over the last 200 years because of the enhanced greenhouse effect, and this is mainly due to fossil fuel burning and farming, leading to CO2 and methane into more of it in the atmosphere, reflecting more of the energy, so putting a thicker blanket on. And there are three main impacts you need to know about. That there are changing rainfall patterns. Sometimes there's more rainfall, sometimes less, sometimes in the same places, just at different times of year. And this is important because it can have a big impact on food production, the amount of crops produced. Also, it can lead to shrinking glaciers and ice caps. Now, this can have a big impact because many nations rely on the rivers and the meltwater from the glaciers for their water supply. So places like Europe rely on Alp meltwater, and places like India and Bangladesh can rely on the glaciers from the Himalayas. Now, all of this means less water locked up in the ice or cryosphere, meaning that sea levels can rise. So there's your overview on climate change. We then look at the UK climate. Now, what we can see is the main factors are latitude. The distance from the equator is very important. The altitude or the height of the land is also important. It gets colder as you get higher. So areas with more mountains tend to be colder. But also hills can have a very important impact in that there can be a rain shadow. So as the wind blows up over the mountains, it can cause rain on the windward side of the mountain. But as the air then drops, it creates more of a higher pressure and then can lead to less rain on the leeward side. The prevailing wind can have a big important. Where the wind is blowing from will also have an impact on the type of weather and climate we have. The ocean currents, as we talked about, because we get this warm ocean current from the Caribbean, that means we're 3 or 4 degrees warmer than we should be. The distance from the ocean can have an impact as well, in that if you're coastal location, it tends to be warmer in the winter and cooler in the summer because the sea temperature changes much less than the land temperature. Now, when we look at the UK climate, we're driven by these main different air masses. Now, this is a very basic diagram. This is supposed to be England, Scotland and Wales. And if it comes from the southwest, it tends to be warm and wet as it's blown over the warmer ocean. Whereas if it comes from the northwest, it tends to be cold and wet because it's blown from cooler areas. In the winter, the southern and southeastern winds can be quite cool but dry because it's blown over the cool continental land. But in summer, it will bring very hot, dry conditions. And if it comes from the northeast, we can see we get the polar continental air masses here. The climate change, what we're noticing in the UK, well, we're noticing that it's getting warmer, but because it's getting warmer, there's more energy in the oceans, leading to more storms. And we're getting changing rainfall patterns. We're getting more flooding because of more intense rainfall, but we're also getting more drought because we're getting longer dry periods. So in the same year, we might get more flooding events, but more drought events as well. And this is important for our management of water. And here we go. You can pause it here just to see more information on the different air masses. Then we have tropical cyclones. These are formed in warm water where the ocean is over 27 degrees, the air rises rapidly, and when you've got converging winds, these can push the air even higher, and then these start to spin the winds, drawing in more energy, more water into it, creating winds over 75 miles an hour. But as these hit the land, they lose their energy source and then weaken. Now, because they need this warm water, we find them in between the tropics, but we don't find them on the equator because the Coriolis effect is not strong enough there. Now, the main hazards to understand about tropical cyclones are the strong winds, the damage that that can cause, but perhaps the most important hazards are in fact the heavy rain, which can lead to flooding and landslides, and the storm surges. This is created by the less pressure, allowing the sea level to rise, but also the strong winds pushing the water and waves in. And it's important that you look at the two different case studies from a developed country, the USA and Superstorm Sandy, and the Philippines of an emerging country of Typhoon Haiyan. And you need to understand about the social, economic and environmental impacts and the different responses for each of these. And you can see, you can pause it here to find out more information on both of those. Finally, we have drought. Now, it's important to realise there is a difference between arid areas and drought. Arid areas are those which are used to having not much rainfall, desert areas in the tropical areas. Drought is that where the rainfall is significantly lower. Now, weather is a big driver of that. Less rainfall is going to lead to drought. If you get less rainfall, then the water cycle, rivers and groundwater will be affected. But also there can be human causes, taking too much water out for agriculture. Building dams can stop water flowing in some areas, and deforestation can have a big impact on the storage of water within the ground as well. Now, the locations this is likely to happen in is all down to the global atmospheric circulation patterns, and these can change. And climate change is changing that as well. So these are going to happen in places that haven't experienced them before. Now again, you need to look at two different case studies. Developed country USA and Ethiopia for the developing country. And you need to look at what are the impacts from reduced crops, which could lead to starvation or increased food prices, impact on leisure, increasing forest fires, and the social, economic and environmental impacts. But also again looking at the responses, such as transferring water from one area to another, international aid and water rationing. Now, for more information, you can pause it and have a look at the information on screen now. So here again is the overview of the course. Yeah, please feel free to replay this at any time. I hope you found it useful. Thanks very much for watching. Please watch the other videos in the series for your revision. Take care. Many thanks. Bye.